rectangular array of numbers or variables. It's always named with an uppercase letter, and an example there is matrix A. Okay, 1, 2, 3, 4, 5, 6. The elements are each value in a matrix. So in this case, this matrix A would have elements 1, 2, 3, 4, 5, and 6. Okay, the rows are the elements horizontally, kind of like a row in an Excel spreadsheet. Okay, the rows go across. The columns are the elements vertically. So in this case, I have 3 columns here. And the dimensions of the matrix are basically, we name those as M by N, where we name our number of rows first by our number of columns. So in this case, how many rows do I have? 2. Okay, by how many columns? 3. So this would be a 2 by 3 matrix. And that's what we would write. So you just go number of rows by number of columns. Really straightforward. Okay? So today what we're going to do is we're going to just talk about some ways to represent story problems using matrices. And then we're going to look at the basics of matrix operations, which, like I said, is it's fairly straightforward. So it says organize the gas mileage in a matrix. So basically what you're doing is you're taking this table right there and you're writing it like that matrix on the very first slide. And so I'm just going to start here, and I'm just going to go ahead and write the numbers as I see them across. That's all I'm going to do. And then on the bottom, I'm going to put the numbers 25, 24, 32, 49, and 70. So that's how you've organized it into a matrix. That's it. Okay? We just take those numbers, put them into a matrix with the brackets. It says add the elements of each row and interpret the result. So what that means is that I'm going to go ahead and add all the elements of row 1 together. Okay? So if I add the 23, 21, 21, 42, and 61, what do I get?
What's an ABV? 168.
All-purpose vehicle. 168 you said? Let's go ahead and add the next row. 25, 24, 32, 49, and 70.
200.
200. So now it says interpret the results. So what we need to do is look back at our original problem and see. So if I look here for rows, okay, if I look at this row, first row, it was city, and it was the different vehicles, and it was their gas mileage. So what do you think row 1 would represent? Right, the city total miles per gallon if you add up all of these vehicles. Okay, because it didn't say to divide it, it just said to add them up. So it would be the total miles per gallon, okay, total city miles per gallon for all of these vehicles. Row 2 would be the total highway miles per gallon for all of those 5 vehicles. Okay, let's look about the next one. It says add the elements of each column and interpret the result. So I'm going to add column 1. What do I get here? 48. What do I get here? 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 131. Okay, and so let's interpret the results. So what would the 48 represent? Oh, the SUV, the total miles per gallon for an SUV in both city and highway. Okay, what about the 45? Yeah, the same thing. It would be the total miles per gallon for the city and the highway for a minivan. So that's pretty much it. That's all matrices are. It's just a way to arrange numbers. So let's go ahead and look at this one. Okay, it says to find A plus B. Now I want you to just look at that. Okay, and in fact, we could have the answer here in method flat. I want you to tell me, what do you think you should do with the A and the B? Logically. So like, tell me what I would get. Thank you. What else? What else? Yep, and? There you go. That's all you do. All you're going to do to add A and B together is you're just going to add the corresponding parts. So 16 corresponds with -4. So you're going to add those two together. Okay? 2 corresponds with -1. So you're going to add those two together. -9 corresponds with -3. So you're going to add those two together. And then 8 corresponds with -7. So you're going to add those two together. That's all you do. Okay? If it tells you to add, you just add the corresponding parts. Now, this is the exact same 3 matrices. Okay, it's just a different problem. It says find B minus A. So what do you think you're going to do there? Subtract them. Now, this is what I actually do in this case. Okay, what I like to do, since this says -A, I do this. And then I just add the two together.
You switch sides.
I just switch all the signs with A, and then I'll add them together, because essentially, this is what subtraction means. It means plus and negative, right? And so that's all I do. So now if I add those together, what do you get for your first value? -20. What do you get for your next one? Yep. Now, I would highly recommend that you change the signs with subtraction, because I see a ton of mistakes get made. So I would recommend switching signs on those. So far so good. Think you can handle this? Because this is pretty much all we're doing today. Let's look at this one. Find B plus C.
4. No. 3.
What?
3.
Would you do it differently?
So if you remember, it was with the corresponding parts, right? And so I would say that those two would correspond, and these two would correspond, but what corresponds with the -1?
The same numbers. 0.
If it wanted the same numbers, it would list them again.
Would you just do 0?
And not do it at all. Make the same.
This is the thing. You can only add or subtract matrices if they have the same dimensions. If they don't have the same dimensions, you can't do anything. So there's no matrix possible. So you can only add or subtract matrices if the dimensions are the same. And if they aren't the same, boom, you're done. No matrix possible. All right, so now this one is the exact same problem that we looked at in the previous slide, except for now instead of saying matrix A plus B, they're just putting two matrices together. That's it. So what am I looking for my answer? -7. There, that's it. Okay, pretty straightforward again. Questions? All right, now this is where the matrix, the operation is not tough, but what we need to do is switch all the signs. So I'm going to change this to addition, and then I'm going to change each of these signs and make it a lot easier problem. So now, if I add those together, what do I get? -5. So by changing the signs, you've made the problem way easier. So I highly recommend that you do that. Okay? You don't have to, but it will, I think, cause you problems if you don't. All right, so the last thing we're going to talk about is scalar multiplication. Now this is the thing you need to understand. When you see that word scalar, it just means a constant, a number. Okay, a constant or a number. So scalar multiplication just means multiplication by a constant or multiplication by a number. So we need to find 5R. So pretty much today, logic has dictated everything we've done. Okay? And logic is still going to dictate this because if I want to find 5r, what do you think I'm going to do?
Distribute.
I'm going to take what? 5 times every number. That's it. That's all you do. So I'm going to take negative 12 times 5, 8 times 5, 6 times 5, negative 16 times 5, 4 times 5, and 19 times 5. So what is negative 12 times 5? Negative 60. What is 8 times 5? 6 times 5. Negative 16 times 5. Oh, negative 80. That's it. That's all scalar multiplication is. And in fact, you're actually doing scalar multiplication on those subtraction problems. Because when you switch all the numbers, switch all the signs, you're actually multiplying by a negative 1. Yep. We got a few more to look at. So find negative 3r. What do you think you're going to do there? Everything times. So what do I get?
Negative 24, 0, negative 6, positive 3, positive 12.
There we go. Okay, so we got our way through there. Biggest thing to remember is you're just going to multiply. So, and last but not least, this is the very last problem we're going to look at. And this is kind of a combination of everything we've looked at today. So all you're going to do in this problem is you're going to find negative 4a. Okay? So what is negative 4a?
20, negative 12, negative 38, and negative 6.
Woo, somebody's on a roll there. And I'm going to add that to 3b. So I'm going to take 3 times b right now. And what do I get for 3 times b?
45, 25, negative 12, and negative 21.
12.
Keep on music.
Okay, so yeah, there you go. And so now, what I'm going to do is add those together. So basically, you're treating these as 2 individual problems, and then now you're going to put those answers together. So you're just going to add them, and so I get 56.
9, 20.
20, 4, therefore.
Negative 57.
Okay, so there you go. So that's all you're going to be doing. That's all today is. These are basic matrix operations. By the way, just for kicks, what would the dimensions of this last matrix be? How many rows?
2 by 3.
3 by 2. We always go rows by columns. Okay? And so now for your assignment, this is what you need to do. On pages 175 through 176, 13 through 28 all. Now believe it or not, if you actually work on it now, you probably should be able to get done. But remember, this is due the second half of the class on Wednesday. Okay?
So then we can work.
Yes.